Okay, today we're going to talk about graphing major x parabolas. So up until now, we've always taught you in Algebra 1 and in Algebra 2 to graph your parabolas or quadratic equations as opening up or opening down. Okay, today we're going to now opening sideways. Okay, so just like the y-axis, when a is positive, it opens up. The x-axis, if a is positive, it opens right. Okay, because on the x-axis, things get more positive as you go right. Just like major y parabola, when it opens down, a is negative, it's going to open left. So we're going to do the same thing, except we're just going to shift it left and right. Okay, same concept, same steps as before. Here are the steps, and basically these are the same steps as before. We're just thinking sideways. So this is going to be a little bit harder because you're going to have to think sideways. But a good way to think about it when you do it is figure out what h and k are and then turn your paper sideways. And then you should be able to, no joke, that works every time. You should be able to get it, okay? Alright, so number one, let me pull up my notes here. So number one, we want to figure out h and k first, okay? We want to figure out the center. On this particular example, we know x is not being squared, so this is a major x parabola. A is 1/3, so it's going to open right. Now, h and k are always next to x and y, respectively, okay? So since y has a -6 next to it, or -6, I know that this is going to be my k, and therefore this other number is my h. So that's the only thing that's different, so watch how I pick h and k. The -6 is actually supposed to represent k, so it's our minus k, so k is equal to 6. And then the 1 is equal to your h. So our vertex is going to be at 1, 6. So I'm going to plot my vertex at 1, 6. Okay. Now just like before, we used to go left and right 1. Remember the shortcut left and right 1? We looked at the a and we figured out what our points were. We're going to not go left and right now. We're going to go up and down 1. So if I go up and down 1, 1 squared is 1. 1 times a third is a third. So if I go up 1, I'm going to go over in a third. And if I go down 1, I'm going to go over in a third. And plot a point there. Then I'm going to go 2 squared. 2 squared is 4. If I go up and down 2, 2 squared is 4. 4 times a third is 4 thirds, or 1 and a third. So if I go up 2, I'm going to go over 1 and a third. Or down 2, I'm going to go over 1 and a third. Okay? Then I'm going to do 3 squared. If I go up or down 3 from the vertex, 3 squared is 9. 9 times a third is 3. So I'm going to go down 3 and over 3 for the point there. So now we have a few points representing where the parabola should go. We're going to graph it with arrows at the end. Then we need to figure out what c is. So we do our formula for c, which is the absolute value of a. In this case is 1/3. Is equal to 1 over 4c. So 1/3 is equal to 1 over 4c. Here's a little shortcut. When you have two denominators and both of my numerators are the same, or 1, then we could just make our denominators equal to each other. So 3 is equal to 4c. Therefore c is equal to 3 over 4. So we know that our focus is always on the inside of a parabola right here, so we're going to go 3/4 from the focus, and we're going to define where it is. It's 1 3/4, 6, because if this is 1, 6, then we just add a third here, so go 1 3/4, 6. And then we're going to go back 3/4 from the vertex to draw our directrix, drawing arrows at the end of our directrix. And since it's crossing the x-axis, this line is crossing the x-axis, we are not going to start with y today, but x is equal to 1/4, and that's it. Okay? And that's how you do number 1. Okay? Any questions on number 1? Number 2, I'm going to do it one more time, just showing you how I did it. Okay? Number 2, again, we have x is equal to 1/4 times y minus 6 squared plus 2. X is not being squared. X is the only term not being squared, so therefore it's a major x parabola. A is equal to 1/4, so it's positive, so it's going to be opening right. So we need to figure out our h and k. Looking at here, we have y minus 6. This must be our k term because y is next to our -6 is next to y, so it's supposed to say y minus k. So k is equal to 6. And this must be our h. H is equal to 2. Therefore, our vertex is at 6, or I'm sorry, 2, 6, okay? So we're going to plot 2, 6 as our vertex. We know that it's going to be opening right, so I'm going to go up and down 1. 1 squared is 1. 1 times 1/4 is 1/4. So I'm going to just go in a little bit. 2 squared is 4. 4 times the 4th is 1. So if I go up 2 or down 2, I'm going to go over 1. Then I'm going to do 3 squared. 3 squared is 9. 9 times the 4th is 9/4, or 2 1/4. So I'm going to go down 3 and over 2 1/4 to here. Plot a point. We got 4 squared. 4 squared is 16. So if I go down, 16 times the 4th is 4. So if I go down 4, I'm going to go over 4, and I have a point here. Draw my graph. Then I need to figure out what C is to figure out what my focus and my directrix are. So I know that the absolute value of A, or in this case is 1/4, is equal to 1 over 4C. So absolute value of 1/4 is 1/4, so we can just make our denominators equal to each other. So C is equal to 1. So I'm going to plot a point here for the focus. Our focus is going to be at 3, 6, and our directrix will be in the opposite direction. 1 unit over, so I'm going to define as x is equal to 1, and then that's it. Okay. So we're not really doing anything new that you haven't done before. We're just doing we're just shifting our problem sideways now. Okay. Any questions? Raise your hand if this looks familiar from Friday. Okay. This is different because it's sideways, but it's still the same process. Question? Okay. You good? Okay, so let's have you discuss with your neighbor. Let's have 1 still at 2 is about number 1. And then 2 still 1 is about number 2. Ready, set, go. Okay, number 3. So we got x is equal to negative 1/4 times y plus 4 squared plus 1. Okay, write this down. We'll work this out together. Okay, on this example, major X or major Y? How do you know it's major X? X is not being squared. Good. Now, let's get open left or right.
Left.
Why?
A is negative.
A is negative. Good. Did y'all get that? Super important. That's where you first start. Okay, so since it opens left, what's my H and K?
Negative 4, 1.
Nope. 1, negative 4. Good. It would be totally wrong, okay, if you put negative 4, 1. Okay? So that's the only thing you have to be careful with, that vertex, okay? Okay, so instead of going left and right 1 like we did on Friday, we're going to go up and down 1. 1 squared is?
1.
Times negative 1/4 is? Negative 1/4. So you're going to put a couple points there, okay? Next, if we go up and down 2 from the vertex, 2 squared is? 4 times negative 1/4 is? Negative 1. So we're going to go up and down 2 and left 1. Good. 3. 3 squared is? 9 times negative 1/4 is? Which is what?
2 and 1/4.
Negative 2 and 1/4. Good. 3 squared. Oh, we just did 3 squared. 4 squared. 16 times negative 1/4 is? Negative 4. Did you all get that? And we can keep doing this across the whole graph. Okay, so that's how you draw the parabola. Okay, major X. Now we have to find the focus. How do we find the focus? What's the equation for the focus? Turn your neighbor, tell it to them, and then we'll do it together. Go. Start with the absolute value of. Okay, so what do I write down? Okay, therefore C is equal to what?
1.
What?
1.
1, right? Because we're going to make our denominators equal to each other because the 4 is equal to 4C, so C is equal to 1. Do you understand that? You haven't been here for a while. Do you understand the lesson so far? Good. You're smiling. Good mood? Yeah. Okay, good. Okay. I'm glad. So now we know C is 1, so we're going to go on the inside of our parabola and mark a point here for C. It's our focus, right? Define where our focus is, everyone. What's the point? And when I say define, what's the... Uh-huh. Nope.
0, negative 4.
0, negative 4. Good. Here's our directrix. Define our directrix.
2 negative.
No,
Oh, just
not y equals 2.
2.
X equals.
X equals 2. This is where you're going to miss points, okay, if you don't define the directrix correctly or the focus correctly.
It's been a while.
Oh, went too faster. Okay, and that's it.
Each period. Second period.
Does this make sense? Yes or no?
Yeah.
Yeah, this is just like Friday, okay? Except it's sideways. Okay? Question? Alright, so let's have you do number 4 by yourself.
Oh, jeez.
Just to start you off on number 4, major X or major Y? Major X. Major X, right? Is it going to open left or right? How do you know it opens left?
Negative.
Negative, right? So major X opens left. Is there an H and K?
No.
No. So this is the part I'm going to start you off with. If there's no H and K, you have to put place values for H and K. So really this is like saying X is equal to negative 2 times Y minus 0 squared all plus 0. So what's my vertex going to be?
0, negative 0.
0, negative 0? 0, 0, right? Okay?
Negative.
Go. So if it's 0, 0, if we go up and down 1, it's going to be 1 squared times negative 2 is negative 2. Up and down 2 squared is 4. 4 times negative 2 is negative 8. Okay, so you should have points there.
Plus,
This is a narrow graph. How could you have predicted that this would have been a narrow graph?
because the larger the A, the more narrow it is.
Good. The larger the A, the more narrow it is, right? What happens if we have a fractional A?
The wider.
The wider it is. Okay? Make sense? Okay. So now we're going to, there aren't any more points I could use because clearly it's going off the graph. Okay, now what's C equal to?
1 over 8.
1 over 8. How'd you get that?
You can put it in the formula.
Okay, raise your hand if you agree it's 1 over 8. Raise your hand if you think it's something else. Y'all trying? We're all tired. It's Monday. Okay, so yeah, that's 1 over 8. So we're going to go left 1/8 on the inside, which is just a smidgen on the inside. So I know your graph will not look accurate, but you can define accurate terms. So let's define where the focus is. What point is the focus?
Negative 180.
Negative 180, good. And define where the directrix is.
180.
Good. That's it. Okay, so we've done all this before from Friday and last week. We're just shifting it sideways. So that looks like you guys are getting it, so I'm going to conclude the lesson there.